Hello explorers and welcome to another video. Today I had a very specific topic that I wanted to talk about, and then I watched this Computerphile video about Feistal's algorithm or cipher and Feistal's cipher, and I was kind of blown away about this concept and that it was pretty simple yet very effective and very interesting. So I wanted to implement it. So let's look at the actual algorithm. There we go. There it is. So this is the Feistal algorithm, and this is the Feistal algorithm. It's, as you see, pretty simple. You have a plain text block up here, and you divide that into two halves. Those two halves you use separately. The right hand side, you first put that into a function, and that can be any function. It can be a hash, it can be a cipher function, it can be something that you key, it can be anything that takes one input and creates another output. And every time it takes the same inputs, it will create the same outputs. And as you see here, you have a round of keys. I will not use keys. I will just try to do this with a SHA-1 hash, but it should, in theory, work with keys as well. So you take the right-hand side, put it into this function with a key, and you get something out. And that what you get out, you will XOR with the left-hand side. And then the left-hand side will replace your right-hand side, and your right-hand side will replace your left-hand side. Then you do it again with another key or with the same function, whatever you like, and you do it over and over and over and over again. And the last time when you're done, the only thing you do is switch the sides over again, and then you have your ciphertext. So how do you decrypt this then? Well, you do the same functions and the same method exactly the same. The only thing is that you switch the order of the keys, so you reverse the order of keys, because otherwise the actual encryption blocks would have the wrong keys. But because you are using the different sides and you XOR, and XOR is a reversible function, so if you XOR something with a value and then XOR it with the same value again, you should get the original value back. So this is something that I wanted to try and see if I can implement with Java in a simple way using SHA-1. So we have our plain text here. The brown fox jumped over the lazy dog, and I have my digest here. If I just print the bytes out, you see that I get the string. If I run the digest, I get string that is not really readable. It's pretty bad. But I should be able to go through this, get some gibberish, and then revert it back. So let's try this out here. First off, I need to have a bytes. Let's see, we need to have two byte arrays. That is our left-hand side and then a right-hand side. And we need to be able to switch those over, so we actually switch sides of them. Yeah, let's start with just have byte right hand side and then byte right, byte left. So we have those two, and then we take left is equal to plain text and get bytes. We should have something that copies bytes. Let's see here. been a while. Arrays, copy of range. So there, and then we do that, and then plain text length divided by 2. So that's our first part. Yeah. And then the right hand side should be the same thing that we have over here, and then that part. So if I print out the left hand side and the right hand side, I should get 2 arrays that are just separated, if I've done this correctly. Didn't do the right hand side correctly. I see. So it's actually the end position. So this should be length then. I see. So now I have the 2 parts here, right and left. So let's see. Our function, public do round, and then we have byte, left, byte, right. So those are the arrays that I want to do something with. And this should be a void function. So do round, left, right. We need to do this static as well. So now we can do a round. And a round is taking the right hand side and creating a hash of that. So we do our digest here. Move this up, message digest, right hand side, and that will give us a byte hash. And do we have an XOR function? We don't have that. Let's see. Bytes and Java. Let's pick one of those up. Should be pretty simple. Yeah, I should go through them like byte array. Yeah, so it should be just a for loop like that. So there's hash. We should use that in order to hash over a function. So left is what we want to XOR with. Y 0. So what's the problem here? Cast to byte. Okay. Fine. So the IDE solved that one for us. So now we have switched those over, but we also want right to become left and left to become right. So I think the smarter thing to do here is to actually do this the other way around. So if we change this over to hash, and then we will XOR left with hash, and we save that into hash. Doesn't really matter which way we go. So if we just create a hash, we XOR with left into hash again, then the hash will have the value with the right hash and left, and that part we want to put into the right hand side. So if we look at our schematic again, if we can do that, we are here now with the hash, and we want to put that in the right hand side, and the right hand side we want to put on the left hand side. So in order to switch those over, we need to clone left over to right, and so array copy, do we have a copy into? No, only copy of. I wanted to actually switch all the values of right into left. Perhaps we just do this with a simple for loop. We don't need to be that aggressive about it. So we do the same thing that we did here, but we will put right into left. Like that. And then we want to put this hash value into right. So it's obviously better to write this as like this, right length, because that's easier to read. We are looping through that like that. And then we do the same for K. Just for readability. And we want to put those into here, and we can do right, we can do hash. They should be the exact same length. And if we do that, as we are pointing to an array that we are working with, this array should also change in our program. So with a little bit of luck, my output here should be jumbled up quite much. Let's see, we just remove that last thing there. Index out of bounds exception. So they weren't the same length. Let's do like this then. I less than left length I plus plus, and here we do left I, nothing there. That would mean that we keep the length of the array, right? Why is the hash longer? Yeah, so there's, as we see here, the lazy dog is longer. And we should also print out the length of each of these, just to see that we have the same length, or else we have done something wrong. Yeah, so both of those are 19. Let's do the same here, hash length and right length. That should also be the same length, right? The hash length is actually 20. Okay, and that's because the hash is padded. Whoa, Daniel! This is Editing Daniel here, and actually all hashing ciphers are fixed length. So that's why you get a different length from the input text and the actual hash. So this hash should always be 20 characters or 20 bytes and nothing else, because it is a SHA-1 hash. So that's our problem there. But we are throwing away the same amount of information every time. So that should be fine for our purposes, I hope. Or else we need to pad this so we can actually do 20 characters. So we get the same length as the hash. And if we do this 2 times, this should end up in jumbled text for both sides. And then we need to have one function that just switch these around like this, around, and this one should do. I'm not thinking at all about performance here, so this performance is not an issue in this code. So there should be functions to solve this, but who cares at the moment? This is a proof of concept. Byte right length. So there we go. That should get 19 characters as well. So we start up with a loop here where we will go through one side. So let's see here. We put right into left and then hash into right. This must be left then. So I left, we put left into hash, right into left, hash into right. That will mean that we will switch them around. And this doesn't really need to put something out. So left, right. So this means that we should get gibberish just switched around. And now comes the interesting part. If we do that again, we should get our text back. That's pretty amazing that you can switch that around, right? That's pretty cool. That's very cool. So let's just for fun do like this and say that we want to do like 100 repetitions here. No, not 100, 99 repetitions. So we do this round 99 times, then we switch it around. We do it 99 times again, and then switch it around. And we get the same text. That's pretty cool. Really cool. So with this, what I created now is actually something that we could say is a keyed cipher that is really strong in order to do some ciphertext and encrypt it, and then you need to have the actual PIN number in order to decrypt it. So if we had the PIN number here, for instance 1, 2, 3, 4, as our rounds number, so that's our PIN number, and then we both need to put in the same PIN number, that would be our secret for this decryption and encryption. So if I do one wrong here, let's say that we do 33, then this would not work. And if I, as you see here, only one part of it actually is not decrypted because they are doing this switching around. But if I was 2 off, or even more, then it doesn't work at all. You just get gibberish. So that's pretty cool. That's pretty cool. So this function that we're using, remember, a hash is a function that you use to take some text and create an output that is different from that text and is not reversible. So if you have some plain text, put it through a hash, you will get some value, and that value, you can't use that in order to create or go back to your ciphertext. There are people that create these gigantic tables where they save all the results so they can go back, but that's cheating. And the hashing algorithms are getting better and better, so it's not really viable to use good hashing and try to reverse those. But SHA-1 is pretty much broken now, so that's not something that you can rely on. But as an example, this is really cool. I'm quite excited about this. I learned about it today. I did a simple implementation and a proof of concept, and it just worked. I'm not sure if you're interested into cryptology or those kind of subjects. I think this is fascinating. I hope that you learned something today. I hope that you found it fascinating. If you have any questions or comments, leave them down in the comment section down below. I will link to the episode on Computerphile if you want to watch that. They go into detail by drawing things up and talking about why it actually is this way. And I hope that you liked this video. Give it a like. Share it with your friends and colleagues. And if you haven't subscribed yet, please do that. And I really hope to see you in the next video.